For many years, humans have been affected by genetic flaws that occurred before our birth. This can also include Down syndrome. Now, what if I told you there was a way to stop this? CRISPRs, or clustered, regularly, interspaced, short, palindromic repeats. These are sequences situated between exact copies of DNA. So when CRISPRs find a virus, they use viral information to code for an RNA molecule. It is then picked up by RNA molecules near the enzyme, which is then picked up by the enzymes. Near the CRISPRs, we have Cas. CRISPRs, we have Cas, CRISPR-associated proteins. These Cas enzymes carry the RNA sequence until they come across a virus that matches the RNA, and then the enzyme is released and is able to destroy the virus.
Explosion.
Now, most genetic scissors only target a reoccurring sequence. For example, AGG10. Then they would also cut out every occurrence of this bad virus. So, therefore, genetic scissors can be a problem because they would cut out the entire genome. On the other hand, these CRISPRs can go into the correct area and inject the correct genome for just this certain sequence. Unfortunately, this biotechnology is not perfected, and it can affect regular gene sequences and actually cause cancer itself.
No! God, please, no! 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 No!
CRISPRs are also very effective for genetic mutations. Years or months to create a certain described gene sequence, but with CRISPR's technology, all alterations can be made at once, which is pretty awesome. So, if we utilize this CRISPR technology in the correct way, we could actually prevent flaws in the human genome. For example, Down syndrome. So, by deleting the certain sequence for Down syndrome, we can therefore make a better all human being. Now, to tailor a CRISPR sequence for the exact Down syndrome, we would actually have to place it in the correct space where the Down syndrome is. Therefore, tailoring it to go find the flawed version of this DNA sequence. RNA molecules would then find the correct sequence and then bind with the RNA enzymes. Molecules would then be formed by CRISPRs, which would then target the error in the sequence, and then with the Cas enzymes attached to the correct area, which then can help improve the DNA sequence.
Oh my god.
This new sequence would only be injected into the specified area and only affect the 21 chromosomes that are being affected by Down syndrome. Yes, the risks are great and maybe cause cancer, but in the future, this could be extremely helpful and help a lot of us in the future to create better people and get rid of diseases that can affect the human race. It's great for this, but since we have started some groundwork and we are making improvements every day, it can be surmised that this could really help those people with Down syndrome and the 6,000 cases every year of Down syndrome that we have.